Hello learners, this is teacher Mylene and welcome to our Science 7 class. Are you ready? But before we start, kindly get your self-learning materials and don't forget to write your name. Try to relax and concentrate. Shall we begin?
Today's video lesson is about motion. With the following objective, describe the motion in terms of distance or displacement, speed or velocity, and accelerations.
After knowing the difference between distance and displacement in our previous video lesson, it is also important to know the rate of a moving body. There are three ways to describe motion. It can be through speed, velocity, and acceleration. Let's take them one by one. Let's start with speed. Speed refers to how fast the object is moving. It will tell you the distance that the object travels in a period of time. To solve for the speed, it has a corresponding formula of v is equal to d divided by t, where v is for speed and t is for distance and t is for time. Speed can also be expressed in terms of miles per hour, kilometers per hour, or meters per second.
Let's have example number 1, solving for Mary's speed. So the first thing you're going to do is to write what are the given. So you have distance is equal to 200 meters and time is equal to 200 seconds. And then the next thing you're going to do is to write a formula to be used. So you have speed is equal to distance divided by time, or you may write the symbol v is equal to d over t. And then the next step is the summation of the formula. So you will write 200 meters divided by 200 seconds. Therefore, Mary's speed is equal to 1 meter per second.
Let's have another example. Solving for John's speed. You have the given of distance is equal to 400 meters and time is 400 seconds. The same formula of v is equal to d divided by t, so you will have 400 meters divided by 400 seconds. Therefore, John's speed is equal to 1 meter per second. For you to understand further, let's try to look at this third example. Lydia De Vega is a world-known Filipino track and field athlete. She can run the 100-meter dash in about 11 seconds. What is the average speed? In order to solve the problem, you have to identify what are the given. So you have the distance is equal to 100 meters and the time is 11 seconds. Following the formula of v is equal to d over t, you will have 100.0 meter divided by 11.0 second. Therefore, the speed of Lydia De Vega is 9.09 meter per second. Aside from identifying the rate of a moving body, we also take into consideration the direction of motion. With this, we use the term velocity. Velocity is a speed in a given direction. And since velocity has direction, it uses displacement instead of distance. As shown in figure 2, the total distance from home to school is 3.0 kilometers, while the displacement is 2.0 kilometers from east, as shown in figure 3. Let us have our first example. Suppose you take 0.5 hour to travel from home to school. Use the information in figure 2 and 3 to solve for your average speed and velocity. First, you have to solve for your average speed. You have to identify the given. Distance is equal to 3 kilometers and the time is equal to 0.5 hours. Following the formula of V is equal to T over T, you will have 3.0 kilometer divided by 0.5 hours. The answer for speed is 6.0 kilometers per hour. Solve for the velocity. You have to follow the formula. Displacement divided by time, you will have 2.0 kilometers is divided by 0.5 hours. The answer will be velocity is equal to 4.0 kilometers per hour to the s. Change in velocity happens when there is a change in magnitude or speed. When there is also a change in direction of motion, and also when there is a change in both magnitude and direction. An object's motion is constantly changing. One cannot achieve a uniform velocity as it travels. You change your speed as you travel from smooth highway to a rough road in the barrio. Sometimes you even change direction. Whenever there is a change in speed, a change in direction, or a change in both, there is a change in velocity. This change in velocity describes the acceleration. Acceleration is the changing of motion of an object, and it describes the rate of a change in velocity. Vehicles rarely moved at a constant speed, but oftentimes they change speed. Consider the figure below. The figure shows the speedometer's reading of a car at 1 second interval with 4 seconds. At the time 0.0, the car is at rest. The car started to move at 0.01 second with a speed of 5 kilometers per hour until at 0.04 seconds, the car's speed is 50 kilometers per hour. To solve for acceleration, you have to divide the change in velocity over the change in time. The change in velocity is the difference between the final velocity and the initial velocity, while the change in time is the difference between the final time and the initial time. Then we have the average acceleration. This refers to the total change in velocity divided by the total time taken for the change. It is expressed in meter per second per second. Oftentimes, the unit of acceleration is written as meter per second squared. Motion with constant acceleration is not common in everyday life. Like a passenger vehicle that moves along a highway, it can move at a constant velocity, changing velocity, or stop as it loads and unloads passenger. When a moving body decreases its velocity, it is said to decelerate. Deceleration is the opposite of acceleration, where the velocity of an object decreases.
Sample problem number 1. A passenger vehicle with a speed of 20 meters per second slowed down to 10 meters per second in 10 seconds. What is its acceleration? The next thing you're going to do is to write a formula to be used. So you will have acceleration is equal to change of velocity divided by the change of time. Take note that in order to get the value of the change of velocity, you have to subtract first the final velocity with the initial velocity. before dividing it by the change of time. Therefore, in the summation of the formula, you will write 10 meter per second minus 20 meter per second over 10 seconds. The result will be negative 10 meter per second divided by 10 seconds. So, the acceleration of the passenger vehicle is negative 1 meter per second squared. Let's have another sample problem. A race car accelerates uniformly from 20 meter per second to 40 meter per second in 2 seconds. Determine its acceleration. Again, to solve the problem, first you have to write the given and the formula. So you will have initial velocity is equal to 20 meter per second, final velocity 40 meter per second, and time is 2 seconds. So the formula for this problem is you have acceleration is equal to final velocity minus initial velocity divided by time. Again, you have to subtract the final and initial velocity in order to get the change of velocity. So in the summation of the formula, you will write 40 meter per second minus 20 meter per second. The answer is 20 meter per second divided by 2 seconds. So therefore, the acceleration of a race car is equal to 10 meter per second squared. That's all our topic for today. I guess you're now ready to answer the following questions. Activity number 2. A racehorse coming out from the gate accelerates from rest to a velocity of 15 meter per second west in 3 seconds. What is its acceleration? And that ends our lesson for today. Thank you for watching.